We know plants lose water as water vapour through their leaves. Put simply, in transpiration, liquid water in the soil passes into the roots, travels up the stem or the trunk to the leaf, where it exits to the atmosphere as water vapour through thousands of tiny pores in the leaf called stomata. At the same time, carbon dioxide can enter the stomata, and that's used in photosynthesis. So the loss of water from the leaf is not a problem in exchange for the carbon dioxide, as long as there's enough water in the soil to replace what's being lost. The problem arises when there isn't sufficient water in the soil that's available for the plant to use. In this condition, the plant could undergo water stress and it could start to wilt. Now, wilting is a visible sign of water stress, but it's preceded by the closing of the stomata. So closed stomata will impede the entry of carbon dioxide, which will affect photosynthesis, effectively reducing it or stopping it. And that's going to affect the plant growth and crop development. So it'd be quite interesting to be able to measure the passage of water vapour through the stomata. And that measurement is called stomatal conductance. So a change in stomatal conductance could be an early indicator of water stress. So the AP4 porometer measures stomatal conductance. Hello, my name's Tony Pilo, and I'm a scientist with the sales team at Delta T Devices. And today I want to talk a little bit about the AP4 porometer, give you a brief introduction. But because it's brief, we won't be able to go into full detail. So I'd always refer you to our user manual, which is a definitive and full instruction for how to use the AP4 porometer. But for now, let's go inside and talk more. So to start with, I thought it might be useful to give a little bit of background information about the measurement principle of the AP4. So this is the leaf with the underside showing. This is where we'll expect more of the stomata to be. Now this is where water vapour is lost from the plant through transpiration. And this is what we want to measure with the AP4 porometer. So if we could place a cup on this leaf, we could collect the water vapour which is escaping through the stomata. That doesn't really tell us a great deal. What would help and be a real step forward if we had a relative humidity sensor inside the cup. So now we can actually measure how much humidity is collecting inside the cup, how much water vapour is escaping the stomata of the leaf. But still, it's not a terribly useful measurement. If we had a stopwatch, now we can start to see some interesting things. Now we can measure how fast the humidity rises inside the cup, the rate of increase in relative humidity. That tells us a lot now about what is happening, but it's only one measurement. It'd be very useful to be able to repeat that measurement and get a repeatable, stable measurement of something that's happening with the leaf. And we can do that if we blow dried air into the cup to reset the humidity level, and if we restart the stopwatch. Then we can repeat the measurement. We can cycle a measurement as many times as we want until we achieve a stable reading, which we can then store as a measurement in the porometer. So the last couple of steps are we'd add a thermometer to the system so we can compensate for the effect of temperature on the measurement of relative humidity. So that's very important. And then automate the process so that we can do it automatically. We don't have to worry about the timings. And that's how we end up with the AP4 porometer, the automatic porometer. So this is the measurement principle behind the AP4. This is where we measure the relative humidity, the rate of increase inside the cup, which is going to be converted into the stomatal conductance for that leaf. But we are repeating the measurement, but when does the measurement start and when does it stop, and how do we repeat it? So the start point for our measurement is the ambient relative humidity, and we use that as a set point in our measurement cycle. The ambient RH is our set point. The finish point in our measurement is when the humidity rises by plus 2.3% above ambient. At that point, the measurement is stored automatically, and then dry air is pumped into the head. The humidity in the cup is reset lower than the ambient. The stopwatch starts again from the set point until plus 2.3%. And it will keep cycling through this until 2 stable readings are achieved. And you can set the AP4 so that when 2 stable readings are achieved that are within 2% of each other, there's an audible double beep, and you know you've reached a stable measurement and you can store it. So let's have a look at the AP4. It comes in a carrying case with straps and a shoulder strap for carrying it around the field. and the lid is zipped closed. This is good because it protects the unit and also keeps it pretty clean when you're in the field. So you unzip the lid, straight away we can see that there's a large LCD screen and a large full QWERTY keyboard. This is what you can use for annotating your measurements later on. Around the LCD screen you can see function buttons, and these are repeated on the left-hand side and the right-hand side, so that if you're right-handed or left-handed you can reach them very easily when you need to take measurements. To the side of the unit, the compartment here holds the head, which we'll take out, and the calibration plate. So everything you need to take stomatal conductance readings in the field comes with you inside the unit. Inside this compartment is also a canister, and this canister contains the silica beads which is used to dry the air which is pumped through the head. So it's connected to the main chassis with this tube, and then another tube going to the head where the dry air goes through. This is new silica gel. As it is used, it absorbs more water and becomes less effective. So it's always a good idea to check you have new silica gel inside the canister. This is old silica gel that needs to be replaced. So when it's new, it's bright orange. When it's been exhausted, it goes very pale white. Now, the silica beads you might be using in your Porometer could start off with a different colour when they're fresh and when they're exhausted. So just check what they're meant to look like before you go into the field to make sure that you are using the Porometer at its best. So let's look at the measurement head. I'll just move these things out of the way. So the measurement head is a clip. It opens and closes, and that's what you put onto the leaf. On the top surface, you can see two very distinctive features and one a little bit more hidden. So the big red button, this is what you can press to accept a menu option and to start a reading, accept a measurement and store the measurement. So you can do everything with the red button, which is exactly the same function as the go button on the main body. This little white disc is actually a diffuser covering a photodiode that's measuring the photosynthetically active radiation, the PAR radiation, that the leaf you're measuring is being subjected to. That's a very useful measurement because if you're measuring a plant which is part shaded or part in full sun, you can reflect this in your measurement. So your conductance reading is taken at the same time as a light level reading. And the slightly more hidden feature is this sliding cover, which exposes where the measurement head is. And this window lets you position the clip onto the leaf. It lets you avoid the main ribs or the veins, or avoid dead or damaged tissue, which is going to affect your stomatal conductance readings. So being able to check where you're measuring is quite a useful thing. And we'll have a closer look at the head now. You might be able to see on the lower side this black gasket. But what we'll do is we'll take one of these heads apart and we'll be able to see the features more clearly. So the top half of the head, top half of the clip, we have our red button and we have our white disc over the photodiode and our sliding lid. Underside of here, we have this rubber band. This is quite a soft, pliable rubber. And it's used to gently push the leaf against the measurement cup to create a seal, so we're not losing any water vapour that's escaping the stomata. Embedded in this rubber is a wire. And this is actually a thermistor, which is measuring the temperature of the leaf. And temperature measurement is very important for being able to get an accurate relative humidity measurement. The bottom half of the clip is where we have our measurement cup, where we're collecting the humidity into the cup. At the very bottom of there's a small square fast response relative humidity sensor, and next to it another thermistor for measuring the cup temperature. And this black gasket allows you to swap between a circular cup and a long slotted cup. So this long slotted shape is perfect for when you're measuring long, thin grass type leaves. And you swap this between the two shapes just by loosening and tightening these two securing screws. So that's a very useful feature to have. So that's the measurement head. What we'll do is we'll move the unit back and we'll connect the actual head to the Porometer. There are two connections for the head. There's an electrical one, which plugs in here. And then you need to connect the tubing where the dry air is blown into the head. Now, if I try to read a leaf now, I will get a message on the side of the screen here, looking back, referring back to the last calibration that was stored in the Porometer. If the Porometer detects that the ambient conditions have changed since the last calibration, or it's just been too much time elapsed, some values will flash, either the temperature or the humidity or the time. And this is a prompt for you to think about recalibrating, because humidity and temperature changes throughout the day, and especially day to day. So if, when you try to take a reading, any of these values are flashing on the screen, then you really should calibrate the system. And that's what we'll do next. To calibrate the AP4, we use the calibration plate I removed earlier. This has a configuration of 6 sets of holes. These range from very large to smaller. So these are open stomatal state to very closed stomatal state. So we can generate a 6-point calibration curve for the Porometer. To do that, though, we need to be able to create a source of water vapour which can pass through these sets of holes. And for that, we will use damp filter paper. So the filter paper on the back of this will allow the water vapour to pass through these holes, and we can measure those 6 points. But we need to make the filter paper damp first of all. And to do that, we'll just use tap water. It's important that this filter paper is uniformly wet. We need to avoid creating areas where it's drier or wetter than others. And so, good idea not to crease or crush the paper, which will affect how it absorbs water, and even finger grease might affect how it wets. So what we're going to do is we're going to push this into just ordinary tap water, and we need to remove the excess water from this filter paper. And to do that, we'll use just normal paper towel. So we'll place the filter paper on the paper towel, and we'll cover it with another sheet. And then to squeeze out the excess water, we gently roll, a marker pen's perfect for this, roll the pen over the paper, and perhaps even move the paper to dry part of the towel, and repeat. So now the filter paper should be just the right level of wetness, and we can place this on the back of the calibration plate. To secure that in place, we'll use just normal brown parcel tape, which you need to apply carefully to make sure the filter paper is secured on the calibration plate and that you don't create any bubbles in the tape which will collect the water vapour that you generate. Once you've secured the filter paper, put the calibration plate back into the pouch and leave it for about an hour, and this allows the calibration plate to equilibrate to the humidity you've just generated with the paper. So put this to one side, and we can use this for calibrating the machine next. Turn the system on, and what we would recommend people doing is to attach the head initially to a plate somewhere halfway along the calibration positions, and place this in the box for 5 or 10 minutes just to let the system equilibrate to the humidity we generated through the wet filter paper. So once you're happy that you've done that and your 10 minutes has elapsed, we're going to continue with the calibration process. We'll scroll across to the calibration function and press go. And at this point, we can now look at the ambient humidity and then set that for the Porometer as part of our measurement cycle, the start point of our measurement cycle. So we'll scroll down to the set RH value, Now we need to measure the ambient humidity, and we'll use the humidity sensor inside the head. And if we open the head a little bit and move it gently through the air, we can measure the air, the humidity in the air where you're going to be taking your measurements. So you do this out in the field near the plant you're going to measure. Now we're not able to get an accurate measurement of the humidity because the pump is activating. That's drying down the air, so we're not achieving the true value of ambient RH. So we need to disable the pump just temporarily. And to do that, we'll press the plus or the minus key, which deactivates the pump. Now when we move this through the air, we can get a true value of the ambient humidity. And you can see the value changing on the screen. If you blow across the head, the values change. So we just want to make sure that the value we're seeing here is what the plant is experiencing. So once we think we've got a stable value for the head measurement, we can adjust the set point to just below that value. And we can move this set point plus or minus 5% increments. So we want to be just below the value for the head and then accept that. Once we do that, we can start on position 6 of the calibration plate. So we need to move the calibration plate out of the pouch and we need to attach the head to position 6. We need to make sure that the measurement cup, which is on the underside here, around this black gasket, that needs to be covering the holes in the calibration plate. So we go this way up. We need to position the plate into the head, and we're helped by these location lugs on the side of the head and the slots along the plate. Once we're happy with the position, place it onto the desk so you're not interfering with it, and we can see the measurements appear on the screen, and already we're getting that double audible beep, which tells us that we have two measurements within 2% of one another. So we have a stable reading, which we can accept by pressing the red button or by pressing the go button. We get a prompt to move to position 5 in the plate. So just as before, we'll unclip and reclip the head at position 5, make sure it's located correctly, press the red button and put it on the desk. And again, we're waiting for this double beep, which we've got already. It's very fast because the holes in the calibration plate here are quite large. So we'll accept that calibration reading. We're prompted to go to position 4. So the holes in the plate are getting steadily smaller. And we go to position 4, press the red button, place it on the desk and wait again. You might be able to see the black bar on the screen here moving as the humidity increases and then falling back rapidly as the pump activates, as the humidity drops because of the dry air and then rises again because of the wet filter paper creating our humidity. We have got the double beep, so we can accept that value and move on to position 3. This should take a little bit longer now because the holes at position 3 are much smaller. So it's going to take longer for that humidity to increase in the cup, to go from the ambient to 2.3% above ambient. We've achieved the double beep, which means we have a stable reading. And when I accept this reading, the Porometer gives me an option after 4 points to fit a calibration curve. We'd recommend, if you can, carry on for the full 6-point calibration. Sometimes the local conditions make this difficult. Check the manual. There's a chapter on this, explains why you might want to stop at 4 points. A 4-point calibration curve is perfectly valid. To select that, we scroll across to fit the curve. And what this means is that the Porometer will compare the theoretical values against the actual values we just measured. So if I select fit curve now, the Porometer will estimate the error for that curve fit. And that's what I'll do now. We'd recommend you really to carry on with all 6 positions, but a 4-point calibration curve is quite valid. The manual is useful to look at because that will explain when you might want to use a 4-point curve. It could be that local conditions are very difficult to measure in, very, very, very high humidity, that sort of thing. So we're going to fit the curve now, and the error appears on the screen. If the error is below 5%, then that is a good calibration curve. You can install that into the Porometer. If it's above 5%, I tend to look at the theoretical and the actual values and just decide whether there's one of the calibration points is a little bit too different, too high or too low. And then I will repeat, I'll redo, which you have the option, that particular value on the plate, and then try and fit the curve again. If it's above 10%, you can do the redo some points, but I would tend to repeat the whole calibration process. It doesn't take too long, and it's always good to get a good calibration so that you know that you're going to get the best measurement of your leaves. So I'm happy with this error value here, so I'm going to install this into the Porometer, and then I'm ready to take some leaf measurements. We'll put the calibration plate back into the pouch. And as I said before, it'll stay fresh and usable for a day or two. Recommend making a fresh one each day, at the start of each day, and then leave it in the box, in the case, and then you can, if you need to recalibrate during the day, which you will, because during the day from morning to evening, temperature and humidity is going to change, so you'll need to recalibrate when you're prompted. And the Porometer will prompt you when this is needed. So we're going to select the read function now. And on the screen, we've got on the left-hand side the prompts whereby the Porometer will tell you whether or not the humidity or temperature has changed too much since the last calibration. So not surprisingly, it's 0. There's been no change in temperature or humidity. And on the right-hand side, there's the ability to change the leaf number we're measuring or the plant number, and to add a name for the group. So the group name could be control or treatment 1 or treatment 2. Once you're happy with the settings there, we're going to start the reading. We're going to clip the head onto a leaf. We'll slide the cover back so we can make sure that we're not trying to measure a rib or a vein or a broken piece of leaf. And we'll make sure that the lower part of the head is sealing against the underside of the leaf, where on this leaf we're assuming the stomata are most present. We'll attach the head, close the clip, close the sliding door, and then press read. And what's going to be happening now in the head is the water vapour from the leaf is going to escape through the stomata, if they're open enough, into the cup, and the humidity sensor in the cup is going to measure this. It's going to measure this time it takes for this increase in relative humidity above the ambient position we just set. And when the Porometer detects a value 2.3% above the set point, that is going to be the value it's going to read. When we have two readings close together by 2% of each other, we'll hear an audible double beep. You can, if you want to, using this in the field, do everything just with the red button and the audible signs. So you can press the red button to start the reading, listen for the double beep, and press the red button to accept, and then again to store the reading. We've got the double beep then, so we'll accept this value. And before we store it, we can remove the head from the leaf and then reposition the head in the same orientation as the leaf, because at the moment we store the value of stomatal conductance, we're also storing the value measured by the PAR sensor. And so you want this value to be the same as what the leaf was experiencing. So not shaded by your body or pointing in the wrong direction. It's useful to have this light measurement. If you're not concerned about the light measurement, move the head out the way before you store the value. But we want the light measurement stored at the same time as stomatal conductance. And at the same time now, we can annotate this reading. There's a long line we can add some notes to this measurement. So perhaps this is a shaded part of the tree, or there's a certain treatment happening on this part of the tree. We can annotate our reading here. And then when we press the red button again, we store that value and we're ready to measure leaf number 2. Hello again. I hope this has been useful to you and will help you get started using the AP4 Porometer. But do remember, the user manual is your primary source of instruction and guidance for how to use it. We've got many hundreds of Porometers around the world, and I hope if you just received one that you've got many hours of happy and productive field work ahead of you. Thanks for watching.